Hi everyone, it's Mrs. Martello. We're going to continue working in section 4.1, starting with looking at example 4. Just to make sure that you know where we are, we're on page 177. So in example 4, it says write a linear function f with the values f of 0 equals 10 and f of 6 equals 34. So before we start this question, I just want to remind you a couple things here. We're going to write our linear function in slope-intercept form. So in slope-intercept form, we have y equals mx plus b. The m is our slope and the b is our y-intercept. Now they're giving us the information in function notation. Remember we learned this back in chapter 3. Function notation looks like this, f of x. Remember f of x is just the same thing as y. So keep that in mind. So in this example, when they're giving us these two function notations, I copied them down, they're here on my paper. They're really just giving us two ordered pairs. If we have f of x and we know that equals y, that means that in this example, this x would be 0 and this y would be 10. In the second function notation, the x would be 6 and the y would be 34. So they're really giving us two ordered pairs. The ordered pair for this first function notation here would really be the point 0, 10. And this second function notation would really be the point 6, 34. All right, so now we're going to use this information and let's find our equation. So we have x1, y1, x2, y2. We're going to first find the slope. Remember our slope formula, we're going to do y2 minus y1 over x2 minus x1. That's our first step. Let's plug it into our slope formula and let's find our slope. So our y2 is 34 minus our y1 is 10 over our x2 is 6 minus our x1 is 0. Let's simplify. On the top, I would get 24. On the bottom, I would get 6. Let's simplify more. 24 divided by 6 is 4. That would be our slope. Next up, our second step is now we're going to find our b. Remember, the b is the y-intercept. They gave us the y-intercept already. Look at this point right here. Whenever our x is 0, this point is the y-intercept. The 10, which is the y-coordinate, that is our b. So our b is 10. Now our last step, step number 3, is let's write our equation in y equals mx plus b. So our equation for this would be y equals, my m is 4 times x, and then plus our b, which is 10. And that would be our equation. Let's do another example like this, just so that we can get some more practice. And I'm going to get this down from the monitoring progress questions. So I'm looking down here at monitoring progress 6. Let's write down the two function notations they give us. G of 0 equals 9 and G of 8 equals 7. Okay, remember f of x equals y. This is what we're using. So in this first function notation, even though it's g, it doesn't matter. It doesn't matter what variable is in the beginning, it's still a function. This is x and y, and this is x and y. This gives us 2 points. This first point is 0, 9, and this second point is 8, 7. Let's label these points. We know this is x1, y1, x2, y2. Let's find our slope. We're going to use the slope formula again. y2 minus y1 over x2 minus x1. Let's plug our numbers in. y2 is 7 minus y1 is 9 over x2 is 8 minus x1 is 0. If I subtract, I get negative 2 over 8. Let's simplify some more. I'm going to reduce this fraction. It becomes negative 1 over 4. There's my slope. Now let's find our b. The b is the y-intercept, and again, look at this point right here that they just gave us, our point of 0, 9. That means that our y-intercept is going to be 9. Let's write our equation. Our equation would be y equals negative 1/4 x plus 9. Let's take a look at example 5. Okay, I'm looking at example 5 here. I'm on page 178. So this is a modeling example, real world example where they're using the information. We're going to go through this problem here together. So it says, excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. By 2012, the amount of electricity generated had increased to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. Use the model to predict the number of megawatt hours that will be generated in 2017. So what we need to do here is we need to identify, they're giving us 2 ordered pairs in this information. So we're going to let X represent the time in years since 2007, and Y represents the number of megawatt hours in millions. So we'll kind of just use the word millions at the end. Because the time, X, is defined in years since 2007, the year 2007 means that X would be 0. The year 2012 would mean that X would be 5. So our first ordered pair, X1, Y1, would be 0 and 105, because it said in 2007 we used 105 million megawatt hours. And then our second ordered pair, X2, Y2, would be 5, 219, because again, 2012 is 5 years later, and we're using 219 million megawatt hours. So now that I have my 2 points, I'm ready to find my slope. We're going to do Y2 minus Y1, 219 minus 105, over X2 minus X1, 5 minus 0. Subtract 114 over 5, and then we'll divide to get a decimal here, 22.8. Now we're ready to find our y-intercept. Our y-intercept, we know from our equation, or from our first point here, is 105. We know that 105 is going to be our y-intercept. We do have a little bit more to do to find our answer to this question. So first, let's worry about writing our equation. Our equation would be y equals 22.8x, which is the slope we found here, plus 105, which is the y-intercept from that point. The second part of the question says, now use the model to predict the number of megawatt hours in 2017. Well, that's 10 years after 2007, so that's why they plugged in 10 here. So their prediction would be about 333 million megawatt hours in 2017.